Okay, so today can be easy, I'm hoping. 3, 30, 22. Our objective is to rationalize the denominator of radicals. What the heck does that mean? Rationalize the denominator of radicals. What the heck does that mean? I mean, let's use English, Mr. Davies. It means no square roots or cube roots, no square roots in the bottom, okay, of a fraction, right? That's all it means. No square roots in the bottom of a fraction. Right? We're going to rationalize the denominator of radicals. In English, that means no square roots in the bottom of a fraction. Okay, so here's what we're going to do. Let's look at example 1. There is a square root in the bottom. Can't have that. What I'm going to do is this. I want to change that number into one of these. Well, how about 25? So if I can change that into 25, I can take the square root, right? So I'm going to fix the problem with the problem. So if I multiply by the square root of 5 over the square root of 5, I'll make a 25, wouldn't I? Okay. Now you have to multiply top and bottom by the same thing, always. Top and bottom by the same thing. That's why I like to use this. Because what I'm doing is multiplying by the number 1. Okay, I'm giving you a lot right now, but square root of 5 over square root of 5 is 1, correct? Square root of 5 over square root of 5 is 1. Multiply anything by 1, I do not change the value. The value of the fraction is the same, but it changes it the way it looks. So here's our goal. We want to make this into a perfect square. If I multiply by square root of 5 times square root of 5, I get the square root of 25, don't I, in the bottom. That's good, because we know the square root of 25 is 5, right? And I'm going to go slowly. So what did I do? I wanted to get rid of the square root in the bottom, so I multiplied it by itself, didn't I? I multiplied by itself, because square root of 5 times square root of 5 is square root of 25, and the square root of 25 is 5. So, is there a square root in the bottom? No. Now the top, we still have to simplify the top. 3 times square root of 5 is 3 square roots of 5. Cannot multiply those. 3 square roots of 5 is just 3 square roots of 5. That's the answer. Now it's tempting to want to cancel the 5s, right? It's super tempting. But that is not a 5. That is not a 5, okay? It is square root of 5, which is this number, okay? It's that number. So you can't cancel the, because that's not really a 5. It's a square root of 5, which is that ugly number. You're done. So what do we do? Is there a square root in the bottom? No. How do we fix it? We multiplied it by itself to make a perfect square. All right, let's look at example 2. Hopefully example 2 will be easy, okay? So what I have, if I rewrite it, I want to rewrite the square root of 5 over the square root of 7. It's easier for me to deal with fractions if I make it into 2 different fractions, okay? Okay, I want to make the square root of 7, I want to make it into that number. Okay, I want to make it into that number. Okay, because the square root of 49 is 7. So I'm really just multiplying it by itself, aren't I? So I multiply by the square root of 7 over the square root of 7. Has to be top and bottom, have to be the same. I have to multiply by the number 1. Then I will get in the bottom, or in the denominator, I'll get the square root of 49, right? Which is 7. There's no square root in the bottom. On the top, though, square root of 5 times square root of 7 is the square root of 35. I can't break that down. It'd be great if I could. I can't do anything with it, so I'm done with that. Square root of 35, okay? That's all I have to do. Is there a square root in the bottom? Is there a square root denominator? Nope. Grace says, no way. We're done. these two have the same exact value. I do want to show this to you. These two have the same value. If I went the square root of 5 divided by 7, or if I go the square root of 35 divided by 7, same exact answer, but one is a better form, okay? Why is this important? We're going to learn why this is important later, okay? Now, number 3 has a cube root. It didn't copy very well, but there's a cube root there, okay? So, with problem with the cube root is I need to make the cube root into one of these numbers. I need to make the cube root into one of these numbers. How about 125? 125 is a perfect cube root, okay? So I'm going to multiply this by cube root of 25. Now, that's a little bit more tricky. But if I multiply by 25 times 5, 25 times 5 is 125, and there is a perfect cube root of that. I need to make my bottom, the denominator, into one of these numbers, okay? So, I'm going to have in the denominator, I'll have the cube root of 125, which is 5. Okay, so the denominator is rationalized. The numerator, I can't multiply, so I cannot multiply. That's an outside number, so I have a 6 times my cube root of 25. Those two cannot be multiplied. You can't take the cube root of 25, so the answer is just 6 times the cube root of 25. How am I doing? Okay, number 4 is easy. It's the easiest of all. 4 is super easy. You know why? That's it. Done. Done. Is it rationalized? It's done. Is there a square in the bottom? No. Isn't that easy? That one was easy. That one took care of itself, okay? All right, example 5. Okay. This is where we're going to use the conjugate. Okay, so these darn things come in pairs. You see the something plus or minus, and I'm just going to show up here. The trick doesn't work. Okay, square root of 3, square root of 3, I'll show you. It doesn't work. I want you to watch this because we're going to have to do something else. Okay, watch. If I think, okay, Mr. Davis said just multiply with the square root of 3, right? That's what we get up here. Okay, square root of 3, square root of 3. Problem with this is you get this answer. You're going to get 5 square roots of 3, but then you're going to get 7 square roots of 3 minus the square root of 3. Square root of 3 is 9. You get 3. Okay, I skipped a step, but okay. Here's the bummer. I still have a square at the bottom, don't I? I still have a square at the bottom. What's my goal? My goal is to get rid of the square root. I didn't. Get rid of it all. That doesn't work. So we're going to do something else. So if they come into the plus or minuses on the bottom, we're going to do a different trick. We're going to multiply by the conjugate. Okay, so let's write that down. So the only way we can clear the denominator here is we're going to multiply by the conjugate. Fancy word. We're going to multiply by 7 plus the square root of 3, okay? That's the conjugate. It says 7 minus square root of 3. We just multiply by the conjugate. And the only thing the conjugate is just the opposite sign instead of a... It's just a 7 plus. That's all it is, just the opposite sign. So let's see how that works. I will multiply both top and bottom, numerator and denominator, by 7 plus the square root of 3, 7 plus the square root of 3, okay? How is that going to help? Well, let's check this out. Okay, let's see. This is going to work, but we're going to take some patience to get there, okay? And I'll go slowly to do it. Well, I'm going to go 5 times 7 and 5 times the square root of 3 on the top. So the top part of my fraction, the numerator, is going to be 35 plus 5 square root of 3, okay? So far, nothing. But I need to multiply. So I multiplied by the conjugate. And on the bottom, the denominator, let's see, I'm going to go 7 times 7 is 49. 7 times the square root of 3 is a positive 7 square root of 3. 7 times square root of 3 is 7 square root of 3. I'm also going to multiply negative 3. Negative square root of 3 times 7 is a negative 7 square root of 3. And a negative square root of 3 times a negative square root of 3 is a negative square root of 9. Okay, it's a little bit harder today, but we can do this. Boy, that's good. Do you see why that's good? That's good. Do you see why that's good? What do you see? What do you see? They cancel out. Awesome. And what else do you see? Totally correct. What else do you see? Is a regular 3. Now, before I simplify, are there any square roots in the bottom? No. They're all gone, aren't they? So that conjugate allows this to happen. So let's see, we have an answer. I've got 35 plus 5 square roots of 3 over, well, 49 subtract 3 is a 46. So there's a minus right there, right? Yep. Is there a square root in the bottom anymore? No, we did it. Okay, you ready to turn the page? We're going to do this a couple more times, okay? Thumbs up before I turn the page. Okay, let's take a look at the other side, okay? Now, example 6. Let's go back to this, okay? I have a square root in the bottom. I do, so I'm going to rewrite this as the square root of 3 over the square root of 50. But before I do a lot with this, can I make the problem smaller? If I make the problem smaller, it's going to be easier, correct? So I'm going to make the problem smaller because I know that 50 can be square root of 50. What two numbers would be nice for 50? 25 and 2, right? And I know the square root of 25 is 5, so I've just made the problem smaller. So I've got the square root of 5 over 5 square root of 2. Now I'd like to cancel the 5's, but I can't because that's not really a 5. That's not a 5 at all. That happens to be an ugly number, square root of 5. Don't. That is not a 5. That is not a 5. That is. But here's our dilemma. We've got a square root of 2, right? Can't have that. If I multiply by square root of 2, square root of 2, Taryn? Oh yeah, my bad. Thanks, Taryn. Golly, there you go, thanks. So, if I multiply by the square root of 2 over the square root of 2, I would get a square root of 4, right? And the square root of 4 would then not be a square root anymore, right? So, I multiply by itself, and let's see what I get, okay? So then I'm going to get square root of 6, because you can multiply a square root with a square root. Thanks, Taryn. I almost made a mistake, didn't I? And then I'm going to get 5 times the square root of 4. You see where I got the square root of 4? Square root of 2 times square root of 2 is square root of 4. And then what do you see? Square root of 4 is 2, right? And so I'm going to get an answer of the square root of 6 over 10. There's no longer a square root in the denominator, okay? Thumbs up? Okay, good. All right, example 7. It's the same process except if we have an x. That's okay. So watch this. I'm going to multiply by the square root of 3x. So I'm really multiplying it by itself, aren't I? Right? Well, let's see how that's going to help me. In the denominator, I'll get the square root of 9x squared, won't I? I'll get a 9x squared. And then that's going to, what's that going to become? Just a plain old 3x, right? I like it. Square root's gone. For the numerator, that's an outside number. That's a whole number times square root of 3x. I cannot multiply those because that's a whole number. So I'm going to have an answer of 5 square root of 3x over 3x. Okay, what do you think? How am I doing? All right, last problem. Am I going too fast? look. Last problem. Slide it up. Okay, what's our dilemma? What's our conjugate? What's our conjugate? What's our conjugate? We need the conjugate. We need the conjugate. What is it? Yep, it's going to be a 2 square roots of 3 minus 3 square roots of 5. Ooh, this looks hard. I think I can do it, though. So I have to multiply top and bottom by the same because that's the number 1. That's called the rule of 1. Not that you care about the rule of 1, but you have to do it, rule of 1. Because you multiply anything by 1, it doesn't change the problem, okay? So I did the conjugate. I did the opposite. Opposite. 2 square roots of 3 plus 3 square roots of 5. 2 square roots of 3, subtract. How's that going to help? Well, let's distribute this. This times this times this. And on the numerator, or the top part of the fraction, we get 10 square roots of 3 minus 15 square roots of 5. Okay, so far so good. On the bottom, the denominator, all right, let's multiply this out. 2 times 2 is 4, and the square root of 3 times square root of 3 is square root of 9. 2 times negative 3 is a negative 6, square roots of 15, because of 3 times 5. The inside, 3 times 2 is positive 6, square roots of 15. And the last term will give me 3 times 3, negative 3 is a negative 9, square roots of 25. Okay? All right, I just FOILed it out. That times that, that times that, that times that, that times that. Okay? Now, how does that help? Hopefully, it seems obvious. Do you guys see it? How does that help? Maddie, what do you see? What do you see up here that's going to be cancel out and all that good stuff? Do you see anything?
The 2 6
Gone. Boom. Okay, awesome. Do you see anything else?
No, but Scott does.
What's that right there? Grace, tell us. Yeah, the square root of 25 is a plain old 5. Okay, now, oh, I see one more thing. Do you guys see one more thing?
Square root of 9.
Which is what?
3.
Now, before I fix it and tidy it up, are there any square roots left in the bottom anymore? They're gone. That's our goal. Our whole goal is to get rid of square roots at the bottom. So let's see. Top, or the numerator, 10 square roots of 3 minus 15 square roots of 5. On the bottom, I'll have a 12 minus 45. Okay, see the 12 and the 45, right? And then last but not least, what is 12 minus 45? What is that? A negative 33, I think. 10 square roots of 3 minus 15 square roots of 5. Done. Done, done, done. What'd you think? Okay, homework. We're going to do a little bit of homework today. It's out of your journal. I'm going to have you do page. Okay, it's going to be in your journal. Only the evens, though. I'm not going to have you do them all. Page 113. Page 113. We're going to do 2 through 26 even. We're going to take a little bit of a brain break, and we're going to come back, and we're going to work.